Hello and welcome to another tutorial. So this time around we are going to be continuing to be working within the AI framework that worked within quite a few videos now. And what we're going to be doing is basically doing a big sort of redesign of the point of interest system, and in particular the look at aspect of that. So that's something that it's still it was a very bare bones system that was set up, essentially as a minimum viable for what I needed. But now I want to make that a bit more generic, make that a bit more flexible, and also make that it is something that those behaviors associated with it sit down in the core of the actual AI system. So that's what we're going to be working on. Now, in terms of with this code, as I said, I'm working in the AI framework. So in the description, you'll actually find 3 links. The first link will be to the code as it is at this current point in time when I'm starting the tutorial. The second link will be to the code as it is at the end of the tutorial, and the final link will be to the completed package. Now, depending upon when you're grabbing that package relative to when this tutorial has been done, there may be further additions that have happened there, so that's just something to be mindful of, that there could be further additions and updates there. So let's dive on in. So the current way sort of points of interest work is incredibly basic. It is heavily reliant on very specific classes existing and providing information. And so I want to begin the process of sort of restructuring this. And so, similar to what I've done with other areas, a big part of that is going to be setting up a number of interfaces. The other thing I'm going to do is, and this is something that is case of from the very beginning of this project, I've had this framework essentials section. So the idea behind that framework essentials one was essentially it was pretty much a bit of a kitchen sink. It was where I generally kept things that I needed, but that I wasn't refactoring at this particular point in time. So as I go through and refactor things, this framework essentials, the intent is that it gets progressively smaller and smaller and smaller. So one of the things I'm going to do, because I will be having multiple things that fit into this, I'm going to create a new folder here. And this is going to be character core. And then similar to what I've done with other ones, this is going to have an assembly definition because I want to have that enforcing of namespaces and that nice clean partitioning. So we'll set up our root namespace. Now in terms of other ones that this depends on, character core is going to need to be able to refer to a couple of things. The main one that I want to be able to have here is our common core. So the idea is that common core should be something that everything can refer to, but then character core is one that is used by other sort of separate ones. So that looks good. Now there will be, as we add in different functionality, there will be additional things that we set up for this. But for now, this will be our character core. So it is going to get a folder here, and this is going to be our look at system. So eventually things like navigation, stuff like that, will get moved down into this as well. So first thing I want to do is define a few interfaces. So one of these is going to be the look handler. So we'll have a look handler and we'll have a look target. And I'll explain sort of the difference between those in a moment. So a target is pretty straightforward. It is going to be a thing that we can look at, and its primary job is to be able to tell us, okay, where is the location we need to look at? The look handler, on the other hand, manages figuring out where it should currently look, whether that's a look target or whether that's some default orientation. It's its job to figure that out. So those are the two main interfaces we'll have. Then we're going to have our LookHandlerBase. So this is going to provide the base logic for our look handler, and we'll also have a LookTargetBase. That's good. So we've got those interfaces set up. So now let's actually populate the main content of these, because these are pretty sort of core ones we need to get set up, and then we can start updating the behaviors. Updating the behaviors is actually going to be one of the more involved and honestly a little bit more painful parts. That's something where that updating of those behaviors, it is a section of this that I will be upfront is just pretty repetitive and mechanical, but I think it's important to actually show it from the point of view that it makes it clear sort of what's involved when you're doing a large update like that, which I think is helpful to actually see. So, okay, let's update our look handler and look target interfaces first. So we'll start with our look handler. So this is a public interface. Now, we don't need mono behavior there, but I do want this to be a locatable service. So this is, again, tying into my general philosophy for how I've been decoupling things, is I want to achieve that decoupling by using interfaces and then making locatable services. That just allows you to swap in your own versions very, very easily, which is the main goal. So we're going to need to be able to set a look target. That's going to take in a transform. So we could set a look target by providing a particular transform. Or we could set a look target by setting a specific location. Now previously, we only really supported being able to do this via a transform. So we want to have a few more options in this case. We want to be able to clear the look target. Now this is something where supporting the transform of the position, eventually we might also want to support providing just that look target interface as well as an option. Now I want to also have logic here for determining the best look target. So that's going to need access to our blackboard because it will output to that. So that's our in blackboard. Then what it actually outputs is we get out of that a game object. So that is our out look target game object. And we also get the actual location. So this is out look target position. So, okay, we've defined what we want that interface to look like. So this is the thing that handles doing the actual looking. Then we have our look target interface itself. It's very simple because it has very little it needs to do. It is something that is locatable, because that's also a handy thing of still just making it that we have an easy way to search for look targets. So all this needs interface-wise is a vector3, and this is get location. Now, there is a reason I am doing this as a function rather than as a property. So get location here could be as simple as return getting the position from a transform, maybe offsetting it. Could be as simple as that. But it could also be more complex. There could be further logic that's happening there. So because this is something where I can envisage scenarios where there is more complex logic happening and where there is sort of a potential for a mild amount of expense there to it, likely low, likely very low, but even still, using a function signals that, okay, this is not just trivially cheap. We can't assume that in all cases. So that's good. That gives us our actual look target. Now, our look target base, we'll set up that next. It's pretty straightforward. We do want it to be a mono behavior. And we do use our look target interface. Now, I will get rid of start like that. Now, this doesn't need to be an abstract class, but what I will do is I will set up a customized add component menu for it. So this is character, and we'll just call this character look at target. Good. Now, in terms of implementing this interface, the get location, pretty straightforward. So what I will do is, because this is something where we might want to have an offset, I'm going to have a vector 3, and this will be our offset, which I'll just explicitly default it to 0. I'm going to have another serialized field, and this is a transform. Now, this will be the target transform, but that target transform, I want it to be allowed to be null. So I'm going to label this as an override transform. So what I will then have here is a protected transform. And I'm going to call this the target transform. So what I'll say is, okay, well, if override transform is not equal to null, then we use it. Otherwise, we just use our own transform. So that works well for that. What that then means is we can have a vector 3 target location that just maps to target transform position plus our offset. And then what we return here is we return our target location. So this just allows us a bit of flexibility. We can have this script and we can just throw that onto anything and that will work. Or we can actually customize the transform if we need to. So that's good. What I'll then do is we'll have a protected virtual void awake. And all I'm doing here is with our service locator, I am registering, and I want to register this as a look target. That's good. We're registering this, and the context is of the game object we are attached to. So that looks good. That's all that the look target base actually needs to do. There's very little to it, as there should be. Now, a LookHandlerBase, that actually has a little bit more logic to it. So this one, I'm going to make abstract because there is common logic I want to do, but there's a lot of things that I don't actually want to implement. So I'm going to have that be LookHandler. So there's going to be a bunch of interfaces we have to actually work with and populate. We'll get to those in a moment. Now, in terms of sort of how we can look and things like that, well, we do already have some logic for doing this. So if I go to, I believe it's in my simple AI character. Nope, might be in base AI, because these will end up changing. So these have a bunch of key settings, and actually a lot of this logic here is what we're wanting to transfer over. So I'm going to directly bring these ones over. And what I'm going to do also is, as I bring these over, is I'm going to remove them from here. So there's a bunch of things here that we don't make use of. So all of those ones, the sensors use a different system now. The debug option of being able to draw the look direction, that's pretty handy. So I'm going to bring that over. But then a bunch of the rest, I'm not. So this side of stuff here, nope, we don't need any of those. Our desired yaw and pitch angles, those, yep, we definitely want to bring those over. So I will bring those across. Now, what this did have, we don't need any of this stuff from updates. So again, just going through this process of deleting things that we don't need. The late update side we'll get to momentarily. But so this did have stuff for storing our look targets, things like of that. But what I want to do is work with this a little bit differently. Because this can, we can set a look target based on a particular transform. We can set it based on a position. So there's a few different sort of options that we've got there in this regard. But also we potentially could be using the actual look target if we can. Like that's the ideal. So what I'm going to do is actually have a few properties here for tracking what I'm actually looking at. So I'm going to have, well, a transform. So we'll have our look or desired. Actually, we'll call that, I'm going to prefix these with target. Have look transform. Now that one, although we already know it's going to be null, I'm going to be explicit. Again, it just helps with clarity. Look target. Target, and that is our look interface. Again, defaulting that to null. The other one that we could be given is just a raw position. Now, there isn't a way for me to set a vector3 normally to null. So if I do the question mark, then I make this nullable. So then I can have target and look position like that. So what this does is this gives me a set of ones that can be populated, and depending upon which one is populated, that will determine how and where I'm actually looking. So good so far. So one little bit of housekeeping is in our virtual void awake, I need to talk to the service locator, and I need to register as a look handler myself and for this particular game object. So that's good. So, okay, let's populate the logic like the clearing and so forth, because those are straightforward. So these clear, I'm just going to copy and paste this. The reason being that all I then need to do is just delete that. So that's good. Clearing the look target, really straightforward. Now setting the look target. Well, okay, we'll get to that in a moment because we've got this determine best look target. This, I actually want it to be abstract. I don't want to provide an implementation here. I want the child classes to have to actually provide that logic. So, okay, good so far. Well, when I set look target as a position, I want to null out those, and I want to have target look position like that, and this just returns true. So that's good. Now it's a little bit more involved when we pass in a transform. Because, okay, well, if the in transform is null, we return false. So it's invalid. Otherwise, what we're going to do is, okay, well, look transform. Yeah, we know it's valid, so at a minimum, we could set that. Okay, so we've ruled out that the transform is null. We could just set the transform there like that. And we'll default to returning true. Now, the thing with this is, okay, if I, on that transform, that could be on a game object that actually has a look target setup on it. So what I'm going to do is I will leave that populated, but then here do a service locator, an async locate for a look target, and the context for it is the inTransforms game object. So we look for it in that context, and the search mode will be local only, and we provide our little function here. So this gets our locatable service. So all that will do, if successful, is it will populate the target look interface with look target and for the found service. And then what I will also do is the look transform will go to null. And what I will also do, and this applies in both cases here, I'll set the look position to null, and I will set the look interface to null. So the idea is at the moment that only one of these will ever be valid. If we've set a position directly, then only position is valid. If we have set a transform and it has an interface, then only the interface is valid. Otherwise, if we have set a transform and the interface isn't valid, it'll just stay as being that transform. So, okay, that's good. So a lot of the logic for doing the actual looking is in this late update function here. And again, we can get rid of this current and previous look target. And I'm going to initially bring that all across. Now, that also means that our base AI script ends up doing nothing, and we're going to end up deleting a bunch of those scripts, which is cool. Lets us get rid of stuff. Always handy. Less code, better. So, okay, so far so good. So the actual looking at logic is going to remain here in our late update. Now, with this, I want to simplify some of these things a little bit and change how these things work. So, okay, the first question that we're trying to answer here is, do we have a look target? So F has look target. So in terms of what that would look like, for now I'm going to have that just be a protected bool has look target. So that is true if target look transform is not equal to null, or if our target look interface is not equal to null, or if our target look position has a value. So if either one of those three are true, then we know we've got a look target. So that's good. Well, then the next thing is to figure out, okay, well, what actually is the position that we should be looking at? So, okay, going to have a protected vector 3 look position, or look at position. So this one is a little bit more involved, so I'm actually going to do this as a more full-featured looking one. So if our target, and we have a look transform, is valid, then we return the position. Otherwise, if we have our target, and we'll do the look interface, so if that is not equal to null, then I return, and from the look interface, we get the location. Otherwise, we check, okay, does the look position have a value? If so, we return it. And then, okay, well, if we don't have anything, I'm going to return common core constants and an invalid vector 3 position. So, okay, that's good. We've got something that can check each of our ways of providing that look location. So what I need to do here then is I need to have vector 3 current or desired look at position, and that is our look at position. Because I might use it in multiple places here, I like just the idea of caching it. So that's our desired look at position. Now the other thing I'm going to do here is a little bit of renaming to make it so that things are following the new naming convention that I'm following. So that's just an important thing. Keeps everything cleaner and neater. And because the rename tool is there in most IDEs and works quite reliably, it makes our life a lot easier. So, okay, we get the position. We follow this same logic as we did before. We don't need to do any changes there. We can update our desired yaw and pitch values. All of those are good. Now, this we used to check if we had a previous, if that was not valid. We don't actually need to do that. We can just default to always returning to look forward. I think that's completely fine. Then we can check, okay, do we have adjustments that we need to make? If we do, then we can update particular ones here. And what I will do is I will actually bring those into here. So we don't keep adjusting the rotation if there's nothing that we need to be doing. We only adjust it when we actually have detected that, yes, there is a change between the current and desired for either of these values. So that looks good. That's those functional. So that's the core logic for this, now's where it gets to the bit that's a little bit more interesting. Because now what we need to do is we need to actually handle removing our actual AI logic. Because what I'm going to now do is in our framework essentials. So those are here. So we have these AI scripts for simple AI character. That is going to be one of those things where if I take a look to see any references in the scene, we know all of our prefabs have that attached. So that's fine. It just means that what's going to happen is I need to actually update a bunch of things. So simple AI character is going to go. In common, base AI is going to go, so we'll actually just fully delete that folder. We still have stuff in navigation, which is fine. So that's good. So navigation can stay. That is eventually going to be refactored as well. Now, prefab and everything wise, this is where we start to need to make some updates, because all of our prefabs used to have our logic for doing the lookat. So we need to actually modify all of these. And because we got rid of scripts, our prefab is going to be grumpy at us, which is okay. Because what I'm going to do is we'll see what stuff we can get rid of. So we'll have this script that's able to be gotten rid of. And what we can add, and so our point of interest functions, those are invalid and will need to be updated. That's fine. Because what we can actually then add is under character, our look at target system, and we need to link up the head bone. And we did have a slight offset with this to the actual head, because I think the head's there, and yeah, the actual look point is a little bit higher. So that update we're going to need to apply to all of our prefabs. Now, because we were using prefab variants, we'll see we don't need to go and fix up that missing script in these other ones. These other ones here are fine. So it's just the base ones that we have to fix up for each of them. So in each case, there's a script to remove, and we add look at target, and we link up the head and provide the slight offset. So that's good. So we've updated our behavior tree. And we haven't updated our state machine one yet, so we'll do that next. So lots of bits to update with this, and this is, intentionally I made this a breaking change because I wanted to see what bits are going to be pretty grumpy at me. That's good. We did update that one. So then the last one is our standalone state machine. Again, we link up our look at target and again link it to the head. Okay, so that's good. We've got that core logic set up there. So far so good. We've managed to update those different bits and pieces. What I then want to do is things like our actual look at systems. Because if we look at where our code for those currently sits, So what we currently have is our actual, if we take a look at a bunch of the different ones, look at point of interest sits in the samples logic. So I want to move that action up to a sort of common set of ones because we already have our BT common folder there. So, okay, BT action wise, I'm going to move look at up to our hybrid GOAP one. Now, a lot of things are going to get grumpy. That's expected, and that's okay. So it's going to get grumpy. The state machine ones, we're going to move that as well. So that's state machine action moves. In terms of our goals, our look at goal is going to get moved up to the common as well. And then what we'll find is we have things like our decorators. Those also need to actually move because those now belong at that higher level. So we're going to move that, which means we can get rid of that folder. We'll find our nodes. Well, those need to move as well. So I'll look at and select point of interest. Those both get moved. So we're breaking a lot of things at the moment, which is fine. So services, it's actually the whole lot ends up being able to move because we've only got that one custom one. So I'm going to move that. More things that will break, which is fine. So that looks good. Our goals, we've moved those. Our state machines, the standalone ones are fine. But we do have a couple of states that we can move up as well. So, okay, we have moved a whole bunch of files, a whole bunch of ones, and there's going to be a lot of things that are pretty darn grumpy at us. So we're going to look at starting to fix those bits where it's grumpy at us. One of the things is going to be, well, our hybrid GOAP eventually is going to need our character core because it's going to be having behaviors that are needing to talk to that. So it needs that. Our demo scene sample logic, that also needs a character core. So those are the easy ones. Now, we have a lot of files that need to be updated because look at point of interest, a lot of these things, they're now in a different namespace. So they have to be set up a little bit differently to make sure that they are consistent. You know, we could choose to not do that, but that would not be great. We should be keeping everything consistent. So that looks good. Okay, so the services, that actually ended up in the wrong location, so we're just going to fix that up. Shouldn't be under hybrid GOAP, it should be under the behavior tree. So that looks good. So behavior tree has access to common core and the framework essentials. It's going to need character core as well. And let's load up that. So we've got our different behavior tree related ones that need to be updated. We've got our decorator, we've got 2 action nodes, and we've got our actual sort of service. So these all need to be updated. So with these, the update process for them, one big thing that all of them need, because of where they are now located, because they're now in our behavior tree namespace. So that's the first thing I'm going to do, just so I don't miss that for any of these, because that's actually really important. Again, this is one of those things where it'd be easy to skip it during refactoring, but it's something where if we make sure that we do it, then it's going to mean that we have stuff properly there and updated, and I think that just makes it much better. Now, in terms of any sort of changes that we need to do for this, okay, then in terms of sort of updates to this, so a lot of this is going to be pretty similar, but this used to have a function here for setting a look target. It's actually not a thing we need to pass in anymore. So we can get rid of that, and we can get rid of that bit of logic there. So that's good. The reason is that what I want to do is in my actual owning behavior tree. So if I go to my BT brain base, and if I take a look at with that, one of the things that I would like to add into this is so that it actually has a public, and we'll put this as our look handler. So this is our look at handler and a get and protected set. So okay, we'll have that look handler, and then what we'll do, similar to what we've done with other ones, async locate service. What we are looking for is our look handler. Datable service in service. So very familiar logic. And what we do is we'll set our look at handler like that. And in terms of our search mode for this, similar to what we do for the navigation there, we provide game object and we only search locally. So, okay, what that means is I can now assume that in a lot of the aspects of our behavior tree, that's going to be accessible. So in terms of what our decorator then does, well, okay, the constructor, no different. The actual onEvaluate, well, in this case, this changes to our owning tree and our look at interface. So our owning tree is our I behavior tree. So we'll need to update the I behavior tree interface as well. So I behavior tree, and what that gets is, and we can throw that, I think, just after the navigation interface. I look handler, look at interface. So that's good. Now when we initialize that, I'm going to make that as one of the things that needs to be passed in. So we'll have I look handler in look at interface. That looks good. Decorator. Okay, what we used to do with the decorator, we would try to retrieve the look at game object. That would get output to our point of interest. That's actually still all completely fine. What we want to check though is, okay, well, if that POI is not null, so if it is valid, then our owning tree, look at interface, and we will set a look target, and we set that as POI transform, like that. So that's good. Now, if that didn't succeed, what I want to do is I want to have a position version of this. So I'm going to create a look at, and this will just be, we'll call it position. That would be self.lookAtPosition. So that's good. Because what I want to be able to do here then is, okay, well, let's have a vector 3 for our point of interest position, and we'll default that to our standard invalid one, like that. Then my linked blackboard, I'm going to try to retrieve that. So our common core names, and I'll look at position. If successful, that outputs to POI position, and if that fails, then it will just be our constants, our invalid position. So, okay, if our position is not equal to our invalid one, then, well, we can actually set that. So I'll look at interface, set look target, and our point of interest position. Straightforward. Otherwise, what I will do is I'll look at interface and I will tell it to clear the look target. So that's what the actual look at logic now appears like. So that's a little bit cleaner and a little bit more robust it'll end up being. So that's one updated. We've also got our look at POI here. That needs to be updated. And the logic here is going to be pretty similar. We still don't have that actual function. So all of that side of it still actually goes. And then what this looks like here is going to be very, very similar to what our decorator is doing. So much so that as a starting point, I'm actually going to bring it across because it is so similar and we want to not waste time duplicating things. So, okay, couple of things then about how this should work is, okay, we'll assume if we get to this point we do failed. What that means is I'm going to put that there. Now I'm going to keep track of here our result, which I'll assume by default is that we failed. Otherwise, what we can do is this. Now in this case, we won't set the B result because if we didn't have a position, then we should treat that as failed. So then what it will do is if we were successful, return that we succeeded. Otherwise, we will return failed. That's all we need for the look at. Doesn't need anything particularly complex or different, straightforward. So, okay, good so far. What about selecting the point of interest? Because that was something where we used to have to do a bunch of logic. Well, we actually can get rid of that. We don't need to have this point of interest picking function. So all of that goes away. What I would say here is, okay, owning tree, the look at interface is null. Now what we're also going to do is set our look at position to common core and our names and our invalid, constants and our invalid position. So that's good. So that's what we should do when it's unsuccessful. Now, what we need to do is we need to figure out our look target. So we'll have our game object, look target, game object, which will be null. We will also have a vector3, is our look target position. And again, I'm going to give that some defaults. So first thing I'm going to do is I'm going to say, well, owning tree and our look at interface. I want you to determine the best target. Here's my blackboard. Here's a game object that it could be going to. And here is the position. Okay, that's good. So it's able to look at the particular one. Then what I would do is if I have a look target game object, so if that's valid, then I'm going to return, in this case, it will be succeeded because I found one. And what I will do is I will pass in that look target here. I'll have a look target game object. Otherwise, if our look target position is not equal to our common core constants for an invalid position, so this is going to be similar, except the difference here is we will return this to being a game object that is null. And this one goes to being the position. Good. We don't need to do that logic. And if it gets down to this point, then we know we failed. So that's all of our selection logic and picking logic, at least within the behavior tree, updated. We've still got the service to update. We'll get to that in a moment. But that looks much better. It's a lot cleaner in terms of what it's needing to do. On the service side, well, the update here is going to be, again, very similar to what we just did. Because that picking logic, all of that, we don't need to do those ones that we had before. What we want to do is we want to grab this. Now, the way we set up the logic is going to be a little different in terms of what it's returning, but otherwise, it's pretty much going to be the same. Look at interface is null. We return false. If it was successful, we return true. So if it managed to set one, good. And all we then need to do is get rid of this and this. Now, because this really, in terms of failures, a service should only fail in particular cases. So I'm actually going to make it that it doesn't actually return false for this, except where there is something like a critical failure like that. Because if there's no valid look target, that's okay. We just clear what the look target is. That's fine. So that looks good. So, all right, all of the behavior tree side of things there, we've updated those. Now our base brain, we added in the look handler, so that's good. We do have our population here of these that need to be updated because we have our look at position. So we're just wanting to make sure that things are being properly reset. So that's really important. And there will be other areas where we find that we need to do similar things. So that looks good. And when we initialize here, we pass in our look at handler as well. So that's all we need to change in terms of the behavior tree brain base. Then in our behavior tree instance, we'll find that it's going to be grumpy at us. which is fine. So if we go to our BT instance, we are missing our actual look at interface. So we're going to add look handler and look at interface. This is just making it so that we're properly implementing the actual interface here, so that's fine. Our initialize here also gets updated because we have our look handler. And this, we bring that in. Just need to make sure we're populating stuff. So that's good. So that should make that significantly less grumpy. So, okay, that's those behavior tree related ones updated. Now, it's not going to be just the behavior tree ones that we need to update. There are also going to need to be updates to the actual state machine ones as well. So what I'm going to do is going to close tabs. That works. So there will be some ones that are currently actively complaining at us. That's okay. We want to get the state machine ones updated first, just so we've got everything consistent. So this is updating our look at and select point of interest ones. So those have to change. We'll also find our brain base needs to be updated also. So our state machine, what we'll likely find is that doesn't have character core. So we add in that. Is the one downside of things that you need to remember of updating the setups there in terms of what frameworks are being referenced, but it doesn't take too long to update it, so it's not too bad. So in terms of what we are storing here, I want to also have my look handler, and that's going to be our look at handler like that. So that's good. We will do our locating of that service, same as what we've got here. So service locator, async. So all this is doing is just updating these to be compatible. It is, a bit of mucking around to be doing that, but it is something that the end result is we have code that is more decoupled, and importantly, it means that then updates later on are going to be a lot easier. Good so far. Unsurprisingly, like Blackboard gets updated to also have the look at position, and we grab that out. That just updates everything there. So that's all that changes in the base brain. Now, in terms of the actual state machine itself for doing the looking at, so at the moment, the states within the state machine are a bit more decoupled than nodes are within a behavior tree. So what this changes to for now is a look handler in look handler. And what we store here is I look handler, look handler. It's a little different. And our actual select one is going to be exactly the same. So I'm going to make that same update to it, just because it makes it a little bit easier to just all update them both in parallel, because it is very similar changes to them. good. And the last little bit. So it's going to be a bit grumpy at us. That's okay. We can now go and update the logic for these. But what I will do is I will grab my behavior tree based ones, because those behavior tree based ones are a pretty good representation of what we actually need to be doing for this. So our lookat used to do all of the logic here, and it's this setup in the onEnter internal that we need to update. So what I'm going to do is I'm going to take my logic here, and I'm going to bring that over, because a lot of it is going to be similar. What changes really with this is the actual return values are one of the biggest things that change. So we have our look handler that goes in place of this. Most of it doesn't change. Now, if we failed here, well, we can just return the failure code. Here, changes is, okay, if it failed, we return the particular state machine related one. Otherwise, we return running. And that's it. In terms of updating it, it doesn't need anything more complex than that. And we'll find very similar when we look at the select one. So the select one previously, again, did everything in onEnter internal. So we do the same logic. So exact same process. Bring those over. And again, the main things that will change are how we were returning to how we were referring to the actual lookat interface, and then our return values. So we obviously have our failure one that we use here. And then otherwise, we say that what we've done is otherwise everything is essentially returned sort of successfully. So these can go away. Now, in terms of sort of the succeeded and everything there, what I would say is that we get rid of those. That. So that's good. So the other thing then we need to update is we need to make sure this is within state machine. Like that for both of these. So that's good. Now, we should have a bunch of errors, but these are all within that hybrid GOAP system, which is fine. So understandably, the hybrid GOAP side of things is going to be a bit grumpy, because we have, in many cases, pretty heavily changed the actual interfaces for these. So that does make a big difference there with it. So let's go and update these different actions. So lookat POI is one of the ones that is grumpy at us. That changes to being hybrid GOAP. So might as well do those changes while we're at it. The SM action is going to be grumpy at us too. That also changes to hybrid GOAP. Good, and so that's our main lookat ones there. And our actual behavior tree here is going to be grumpy at us. So this one will need to update the initialize, which is fine. That's an easy one for us to update. In terms of what that should be, that should actually be our look at handler. Now that looks good, but that's going to be trying to find it on our GOAP action base. So we're going to update this as well. So this is going to have a protected look handler, and this gets called look at handler. And we do the now very familiar service locator, async locate service of our look handler. At least the autocomplete is getting a lot better at actually just populating it with exactly what I'm going to be using, which is handy. So similar logic here. That's our look handler like that. So that's good. We should mean we've got some of the errors fixed up, but now we just actually have the main sort of set of errors with all of these, which is all good. We'll get to updating those. We've updated these particular ones, but we also have goal, because that's now in the hybrid GOAP one. So that just makes sure that's consistent. So, okay, now in terms of what these actions do differently and sort of the areas where they're going to be grumpy. Well, for the behavior tree, it's pretty straightforward. We actually can just be deleting these particular ones that were being passed in. The reason being is that they just no longer need to actually do that logic. Our pick and set POI functions that we had, those just go away. So if we check, immediately, a lot less errors, which is great. Our SM action 1, well, that changes a little bit because these go to being our look at handler, like that. But they still get rid of our pick and our set POI functions. So those are still able to be gotten rid of, like that. So that's good. That should make less things grumpy. And it is. Now the ones that are grumpy are our standalone. That's okay, because those ones are going to be relatively straightforward for actually updating them. So if I go to my scripts for our standalone behavior trees, so what I'll do is I'm going to close all of these tabs and we'll update all of these in one go. Because most of these are a very simple standard update to them. So the behavior tree ones in particular, we get to just delete things. Good so far. Just delete things. And same with the FPS one. Okay, so that's good for the individual standalone ones. Now there is a bit more of a change to the actual common one here. So we can get rid of that look at function. We don't need that. We had these point of interest helpers for being able to look at and set things. We don't need them. So we actually get to delete all of that. And that's the update for the standalone base for the behavior tree. So nice and clean in terms of what the actual update is. Now for the state machine, it's going to be fairly similar in terms of what we actually do with that. So again, we can get rid of our setPOI function. And again, we delete that point of interest code. And then these, where we used to be passing in a function for doing the actual look at, these, we just need to pass in the look at handler. So that's significantly cleaner. And eventually I will look at for the state machines, giving them a bit more of a similar capacity to the behavior trees where they can actually just discover this stuff themselves. So that's good. That's all that changes with all of those. So we close all of those tabs. So now we have nothing complaining or grumpy at us. Now, a couple of things we might run into. We want to check, okay, the prefabs still look okay. They still have those goals. They have the actions for doing, look at things like that. But we can see that BT action look at POI still got these here. So we can get rid of that because those are not a thing that we need anymore. They were a necessary thing, but they actually aren't anymore. So all of that gets deleted, because a big part of the goal with this is actually making this logic essentially cleaner and neater. That's really the big sort of part of the goal there. So that's good. We've got the action there. Now what I want to check is to make sure that our prefabs for the individual behaviors are all good, that there's no weirdness there. So they do have the correct linking up. They've got the point of interest. All of that looks good. Now, the thing that none of these have yet, though, is none of them have any linking for our actual setup in terms of the look at handler. But otherwise, okay, so the SM action one has more stuff that can be deleted. Deleting is good. So far, that's good. I've cleaned out a lot of those ones. These all look correct. And this is sort of the area where it's easy for things to go wrong. We'll check the standalone ones that they look correct, which they do. They all look good. Same with the state machine ones, and they also look good. So, okay, that's pretty good. We've got the majority of what needs to be updated. There is a couple of things remaining that we need to actually do. So one of the things is this GOAP brain wrapper. It still currently has some stuff for point of interest. So it still has the picking logic. Now that picking logic is what goes into our look at handler. So what I'm going to do is I'm going to create our AI look at handler. And all of the logic from the brain wrapper is going to go into it. So it's our LookHandlerBase. Good. And then it just needs to override that one function. And the content of it is largely going to be this, to the extent that what I'm going to do is I'm going to initially transfer these functions over and we'll refactor them. So the brain wrapper loses all of that logic, doesn't need it anymore. These are going to go there for now. That will actually change because this will be customized in terms of how it actually behaves. So this gets our component menu. So we have character, and we have character look at handler. Like that. That's good. So, okay. So we'll need to populate the look at handler soon. So in terms of what it needs to do, so it did used to rely on this callback logic before. That's not a thing that we're going to be doing anymore. But what I will do, I will bring this over just to sort of show the process of how I want to refactor this. So, okay. Our priority initially was sort of setting these things. What I'm going to do is initially populate our out values. So that's the first thing I want to actually populate. So first priority is looking to see if we have an awareness target. So if we do, then what I want to do is our target game object. I want that to be the current awareness target because that's where I should actually be looking at. So in that case, we can return straight away. Our next priority is an interaction target. So if we have an interaction scriptable object, then we want to be able to check that this is a valid target to actually look at. What I'm going to do is also rename that to is look target valid. So, okay, if that look target is valid, then again, we have a game object. And again, we return. So the next priority is if we have a focus target. So if we have a focus target, then we want to switch to that. And then our next priority is, do we have a look at target game object? So if we do, then logic is going to be pretty familiar at this point. That's our out look target. It's going to be the current look at target. So we can exit out. So far, so good. Now, the other thing that we could then have is we could have a position. Current look position. If I have a look at position, this is a vector3, and that's our common core constants like that. Output it like that and provide the appropriate default. So if that look target is valid, which the way we can know this is going to get passed in a position. If it is, then our outlook target position is our current look at position. Means we do need an alternate version of this function. Rename this one to in target game object. This becomes vector3 and in target position, and it's valid as long as it's not going to be our invalid constant. As long as it's not that, then it's valid. So that's good. That gives us our lookat handler. So far so good. So, okay, if we take a look at these, the individual AIs have their character lookat targets, so that if something is trying to look at them, we do need to, for our actual player, also add that in. So in our framework essentials, I believe we do have our prefabs for our first person player. So what I will do to this is this also gets a lookat target, and if we open the prefab, that'll make it a little bit easier for configuring it, because where it should be looking at is pretty much the player camera transform. So that's good. So then all of our AIs, we need to give them that actual look handler. So they're look targets now, so if they want to look at each other, they easily can. But we then have our lookat handler. That again has similar sort of logic where, okay, with this, we're going to need to drag this over, and it should use the same offset. So that's good. That's for one of them. We can update this, give it the lookat handler, link that up. So it's a bit involved because we need to go and update multiple ones, but once it's done, then we get a handy setup that we can use, and it works generically, so it makes it much easier for if we want to update this in future, which is good. So then our final one here, can update that, and we will give it lookat handler, look up the head. That's good. So let's test this out. So we've got one here. We can debug and control where they are trying to be looking, so we can see that working. So let's test that out. Between different locations, that looks good. Not seeing the drawing of the look direction, but that's because we need to be in the scene view. That looks all right. You can see they are controlling sort of where they are looking, which is great. That's what we wanted. And we can see the head has turned there to allow them to look. So that's good. What I'm going to do is make sure the debug display is turned off by default. We don't want that on by default. That's otherwise a little bit sort of spammy in the scene if you have heaps of different lines and everything being drawn. So we just need to update our base ones here so that that is turned off. Make it a little bit less noisy. And then what I'll also test is that it works for the actual ones where we're looking at the player. So those look good. Let's go for a state machine first person one though. And with that, they should be here. So I can see them looking at me and I can see their head turning and facing me. So that's good. So we have updated our system to now support having our point of interest, our look at system, be operating in a more generic way. So there's less needing to hook up events in the inspector and things like that. We find the stuff we need via discovery, via interfaces. So that just saves a lot of time with that. Honestly, just really makes our life a lot easier. But that's all set up now. There is, later on, I do plan to do some updates to the actual interactable system and do a similar process there of expanding that, making that easier to work with, and making that more generic. That's sort of a necessary step before I want to take the sim side of things and other areas further. But dive on in and experiment with the code and see what kinds of cool things you can set up. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you are looking for the code for the project, as I mentioned, there are 3 links in the description below. The first is to the code as it was at the very beginning of this video. The second is to the code as it is at the end of the video. And the third is to the completed package. If you have any questions, chuck those in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description as well. But until next time, bye.